My name is Mohammed Layiq Sediqi, the father of the Holophase model, and in this part of our journey, we continue exactly where we left off in episode 3, part 1. In the previous part, we opened the door to something very strange. We said that maybe the most basic layer of reality is not matter, not energy, not even space or time, but a single continuous rhythm that runs through everything. We called that rhythm the holophase, or simply phi. We treated phi as the underlying order from which all familiar physical things are read out, the way many different images can be read out from the same hologram when you shine light on it in different ways. In part 1, we stayed quite gentle. We said, look, imagine reality built not from little hard particles, but from a kind of cosmic choreography, a pattern of timing and alignment. That is the intuition. In this part, we are going to go deeper, but still in simple human language. We are going to ask the awkward questions that any honest listener would have at this point. What is this phi actually made of? Is it a substance? Is it a kind of field? Where does it live? Why has nobody noticed it before? And perhaps the most disturbing question, how can we build a serious scientific theory on top of something we cannot picture and cannot see directly? Let us start with that last point, because it is both the most counterintuitive and the most powerful. Phi, in the holophase model, is fundamentally invisible. You will never see phi itself, the same way you will never see temperature itself floating in the air. What you see are behaviors that depend on temperature differences. Heat flowing from hot to cold, ice melting, air shimmering above a hot road. You do not see voltage itself. You see sparks, currents, lights turning on, devices working or failing. In the same way, you never see pure phase. You only ever see the consequences of phase differences. This is not just a poetic claim. It is a very strict scientific statement. In actual laboratories, when we work with light, radio waves, sound, quantum states, we do not measure absolute phase. We measure interference patterns, shifts, beat notes, fringes, visibilities. Every piece of equipment we build is responsive to how one oscillation lines up with another, not to some absolute where in the cycle number that exists all by itself. In other words, nature already behaves as if only differences in phase are real. The holophase model takes this seriously and pushes it one step further. We say the only operationally meaningful thing is how phi changes across space, across time, and between systems. So, in our ontology, phi itself is invisibly everywhere, but what shows up in experiments are its derivatives, its gradients, its mismatches, and its alignments. If that sounds abstract, let us bring it down to earth with some very concrete examples. Imagine you are listening to two violins playing the same note. If they are perfectly in sync, you hear a single, steady tone. If one of them drifts just a little bit ahead or behind, you start to hear a slow wah-wah-wah beating effect as the two sounds interfere. Your ear is detecting a tiny phase difference between the vibrations produced by the two instruments. Absolute phase does not matter. You could slide both waveforms forward in time by the same amount, and nothing would change in what you hear. Only the difference between them matters. Now think about noise-canceling headphones. They do something clever. They listen to the sound outside, predict its waveform, and then play the opposite waveform into your ear. When the two wave patterns meet, they cancel each other out. The loud world outside suddenly becomes quiet, not because the air stopped moving, but because the phase of one oscillation is arranged to oppose the phase of the other. Again, what matters is the relationship between two rhythms. Or consider a hologram. A physical hologram plate looks like a weird, shimmering pattern of lines and speckles. When you illuminate it in the right way, a three-dimensional image appears, hanging in space. The key is that the hologram encodes tiny phase differences in the light that hit the plate when the image was recorded. When you replay it, your eye and brain interpret those phase patterns as depth, as volume, as objects. In all of these cases, what actually acts on you are differences in phase, not any mystical substance. The holophase model says, let us stop treating phase as a secondary thing and promote it to the central character. Let us imagine that underlying everything, there is a single, continuous assignment of a cyclic order, a sort of now I am here in the rhythm, now I am here at each point of the world, that is phi. And everything we can ever measure is how that cyclic order differs from place to place, from moment to moment, from system to system. But now you might object, Fine, I get that we only see phase differences, but what is phi itself? Is it like a field filling space, like an electromagnetic field? Is it like a fluid? Is it like a sheet or a membrane? Give me a mental picture. Here is the difficult truth. If we stay honest, we do not know what phi is made of, and we are not going to pretend. Phi is not introduced as a new kind of material. It is not another form of energy. It is not some strange fluid that you could, in principle, bottle or heat or weigh. Phi is an assignment of cyclic order, a way of saying, for each point of the world, here is where we are in the underlying rhythm. You can think of it like the phase of the hand of a clock, but a clock that exists everywhere at once, with hands that can move at different speeds and directions depending on where you look. Yet even this analogy is misleading because the hands of a clock are made of metal and they sit in space. Phi is not a little object sitting anywhere. It is more like the abstract angle itself, the pure how far around the circle we have gone that can drive many different physical systems. An example might help. Imagine a huge stadium doing a Mexican wave. Each person is either sitting or standing. The pattern of people standing and sitting moves around the stadium in a wave. What is this wave? It is not a substance. It is not an extra person. It is a pattern in how many bodies are arranged and how they change over time. The Holophase model says phi is like the rhythm that organizes such patterns, but at a much deeper level, beneath all the familiar substances. So no, we do not know what stuff phi is made of, and that is not a bug. It is the point. The Holophase model says, stop thinking that the universe must be made out of some kind of stuff that you could, in principle, scoop up. Start thinking instead that the universe is built out of structured rhythm, out of relationships of timing and alignment that we call phase and phase difference. At this point, it is natural to worry. Is this just a fancy way of saying information? People might think, is phi just another word for information, for bits? The answer is no. Information, in the usual sense, depends on someone reading and encoding something. Bits are symbols we use to represent options. Phi is meant to be more primitive than that. It is not what we know, it is the structured pattern that everything, including our knowing, is built on. You might say that information is like a message written in ink, and phi is more like the rules of how the ink can flow and solidify in the first place. It is prior to the messages that get written. In the Holophase model, you can later build bits, codes, and information theory on top of phi. You can talk about how much information is in a given arrangement of phase patterns. But phi itself is not your knowledge or your beliefs. It is the underlying structure that makes any stable pattern possible at all. So far, we have emphasized three shocking things about phi. First, phi is everywhere but invisible. Second, only its differences and derivatives are ever observed. Third, phi is not a familiar substance like energy or matter. It is an order, a rhythm, a cyclic assignment that sits beneath them. Now let us connect this to the crisis we talked about in episode 2. The modern story tells us that reality is made of energy, living in spacetime, shaped by fields and governed by equations. That story has been incredibly successful. But when we look at what our instruments are actually sensitive to, we see phase, interference, oscillation, and correlation over and over again. The Holophase model is a proposal to shift our ontic starting point. It says, what if the true primitive is this invisible cycle field phi, and energy, spacetime, fields, and particles are all ways of reading or encoding its behavior? If that is true, then the invisibility of phi is not a problem. It is a constraint. It means that any serious holophase theory must tell you exactly how to connect phi to real experiments. It must specify which combinations of phi and its differences correspond to the intensity on your camera, the click of your detector, the frequency of your laser, the path of your particle. It must be very concrete about how you move from this invisible rhythm to visible traces. This is where the strict scientific part begins to do its work. In the full Holophase program, which we will touch on gently throughout these audio episodes and lay out rigorously in the papers, we insist on a very tight rule. If you cannot express a quantity as a functional of phi and its finite derivatives on a finite window with clearly specified error bounds and reconstruction methods, then that quantity does not exist as a fundamental physical observable in this ontology. That is a brutal statement, and it is how we keep ourselves honest. It means that we cannot just wave our hands and say phi explains everything. We have to show step by step how time, space, motion, energy, fields, forces, temperature, probabilities, and everything else can be read from the invisible pattern of phi in ways that can be tested and, in principle, falsified. Let us stay with the invisible theme a little longer because it actually appears everywhere in science. You never see an electric field. You see the force on a charged particle, the spark between two electrodes, the motion of a needle. You never see the curvature of spacetime. You see the path of light bending, the ticking of a clock slowing, the orbit of a planet precessing. You never see a quantum wave function. You see counts on a detector, distributed according to certain probabilities. In every case, the thing we treat as real is, in some sense, invisible. We infer it from patterns in the visible. The holophase model extends this pattern one level deeper. It says, what we now call field or space-time geometry might themselves be like the electric field once was, useful but not ultimate. There could be a deeper invisible thing, phi, whose structured changes give rise to all those quantities. So the invisibility of phi does not make it unscientific. It makes it exactly as scientific as any other invisible entity we infer from data. The difference is that we are proposing phi as the last stop, the thing we cannot reduce further without losing our ability to connect to measurements at all. To make that believable, we need a clear bridge from feature eye to everyday experience. One way to picture this bridge is to imagine a vast, multi-dimensional ocean of rhythm. At every location in this ocean, there is a tiny arrow that points around a circle, indicating where in the cycle that region of reality currently is. This is a way of visualizing phi. The arrow can spin faster or slower, it can have neighbors that are aligned or misaligned, it can twist as you move around, it can form spirals, vortices, and more complex patterns. When many arrows in a region are aligned and spinning in a coordinated way, we experience that as a coherent phenomenon, a beam of laser light, for example, or a stable quantum state. When the arrows are random and uncorrelated, we experience noise, thermal agitation, or classical chaos. The holophase model gives you a language to talk about these patterns of alignment and misalignment, of synchronization and decoherence, of smooth waves and tangled knots. But remember, those arrows are not little physical objects. They are just a way of drawing an abstract quantity that we call phase. The reality in the model is not a sea of arrow particles. It is the full pattern of cyclic relations that those arrows represent. This is also why the holophase model is so strict about falsifiability. Because phi is so abstract, it would be easy to abuse it as a vague metaphor. To prevent that, we embed it in a very concrete set of rules, windows where we read phi, numerical bounds on how well we can estimate it, dual methods that must agree, and a clear dictionary that ties phi's derivatives to measurable quantities. You can think of it like this. Imagine you discovered that all the different languages spoken on Earth were actually different ways of pronouncing a single underlying alphabet that nobody had noticed. You could not just say, "Trust me, this alphabet exists." You would have to show how each spoken language maps onto your alphabet, how you can reconstruct one from the other, how you can predict patterns in new languages that nobody has heard yet. That is exactly the level of discipline the holophase model demands of itself. In part 1 of this episode, we laid out the basic idea, a single continuous phase field, phi, as the ontic root of physical reality. In this part, we have tried to make 3 things completely clear. We have said that phi is invisible and that only its differences and derivatives show up in experiments. We have said that phi is not a familiar substance, not another fluid or field you can picture sitting inside space, but an assignment of cyclic order that sits beneath the things we usually call substances. And we have said that because of this, any serious holophase theory must be built as a rigorous bridge from this invisible order to the visible world, with clear rules for when it succeeds and when it fails. Before we move on, there is one more angle I want to share with you, because it helps answer another natural question. If phi is so important, why has nobody talked about it like this before? Physicists talk about phase all the time, but not as the substance of reality. What is different here? The short answer is that, historically, phase has been treated as a useful side character rather than the main actor. Engineers and experimentalists use phase because it is practical. They worry about keeping lasers in phase, correcting phase errors in radio antennas, tracking phase noise in clocks, and so on. Theoretical physics, on the other hand, has tended to elevate other quantities to the status of real fields, particles, energy, curvature. Phase was seen as a helpful parameter attached to those more fundamental objects. Holophase turns that ordering upside down. It says, take the thing you thought was a side character and make it the lead. Take phase, and not just phase of one particular field, but a single universal phase assignment, and treat that as the ontic backbone. Then re-express everything else in terms of patterns in that backbone. To see why this is not just wordplay, imagine you have a library of many films stored on a computer. You could think of each film as a separate object, or you could notice that all of them are really patterns in the same underlying binary medium. The same stream of bits arranged differently can represent completely different stories, scenes, and worlds. If you focus on the films, you might say, we have one object for each movie. If you zoom down to the bits, you might say, we have one medium, different patterns. Holophase is a bit like zooming down past the level of fields and particles to the common medium that carries them all. But instead of bits, our primitive is this continuous cyclic order phi. Where a digital computer has zeros and ones, the universe in this picture has angles and differences of angles. Where a video file is an arrangement of bits over time, a physical system is an arrangement of phase relations over time. Of course, this analogy is not perfect, and we must be careful. We are not claiming that the universe is literally running on a computer, or that there is a hidden digital code we could print out. The point is more modest and more radical at the same time. There is a single, coherent way of describing all physical behavior in terms of one underlying rhythm, and that description can be tested. This is where the word phi closed becomes important. When we say the world is phi closed, we mean that every physically admissible quantity can, in principle, be written as a function of phi and its finite derivatives on some finite region where we can actually do experiments. Nothing else is allowed to sneak in. That does not mean that we cannot use other words like energy or field or particle. It means that whenever we do, we must be able to translate those words back into the phi language without ambiguity. If we cannot, then we have either invented a fake entity or we have found a limit of the holophase model. You can think of it as imposing a very strict grammar on our descriptions of reality. Phi and its derivatives are the alphabet. Everything else we say has to be spelled in that alphabet. You are free to write poetry, novels, scientific papers, any story you like, but you may not introduce new letters. If you try, the holophase framework will either translate your new symbol back into combinations of existing letters or reject it as meaningless at the most fundamental level. This is a severe demand, and it has two big consequences. The first consequence is unification. If you succeed in spelling the whole of known physics in the alphabet of phi, you have achieved something extremely rare. A single coherent ontology that covers quantum theory, relativity, thermodynamics, condensed matter, cosmology, and information without having to bolt together incompatible pictures. Fields, forces, particles, spacetime, temperature, entropy, probability, and even life and mind all become different stories written in the same underlying script. The second consequence is fragility. Because the rules are so strict, the theory is easy to attack. If someone can show a single robust effect that requires a new letter that cannot be built from phi, the whole proposal is broken. Holophase does not hide from this. On the contrary, it advertises it. In these audio episodes, we keep repeating the same theme. A good theory must be killable. It must draw a clear line between what would count as confirmation and what would count as failure. There is another potential misunderstanding that we should clear up before we move to the next part. When people hear that the universe is made of rhythm or built from phase, they sometimes slide into mystical language. They imagine cosmic vibrations in a spiritual sense, or they think we are smuggling in some kind of universal consciousness as the basic substance. That is not what Holophase is doing. Holophase is not a disguised form of idealism or pantheism. It does not say that everything is mind or that the universe is secretly a person. It does not deny the reality of matter, energy, or fields. It simply relocates them. Instead of being primary, they are now read as structured expressions of a deeper phase field. Mind and consciousness will enter the story later, but they will enter as very particular, highly organized configurations of phi, not as the raw material of everything. In other words, holophase is not everything is mind. It is closer to everything, including mind, is readable as patterns in an underlying phase field. Why insist on this distinction? Because it keeps us anchored in the scientific method. It reminds us that we are not allowed to simply invent explanations that cannot be tested. Every time we say, this is a pattern in phi, we are making a claim about what we should be able to reconstruct from experiments, about what kinds of interference, synchronization, and correlation we should see if we probe the system in the right way. Let me give you a simple image that holds many of these ideas together. Picture a large sheet of water in a dark room. You cannot see the water directly, but you are allowed to throw pebbles in and watch the ripples under a faint strobing light. You notice that some parts of the water respond in a very chaotic way, some respond in very regular patterns, and some regions seem curiously still. Over time, you learn to throw pebbles in certain places and at certain times to generate stable standing waves, traveling waves, vortices, and interference patterns. After a while, you realize that you can use these patterns to represent information, to build crude machines that rely on the timing of the ripples, to transmit signals from one side of the pool to another. You never touch the water directly. You only ever see the moving patterns. But those patterns become your whole world. In this picture, the water itself is like phi. You never touch it as a static thing. You only see its changing patterns. The pebbles and the strobes are like experimental interventions. The standing waves and interference patterns are like fields, particles, and all the other things we usually talk about. The holophase model says we should write our physics in terms of the water, not just the ripples, even if the water can never be isolated as a standalone object. One last concern before we close this part. You might ask, is this just a different language to describe the same old physics? Are we really learning something new or just renaming things? This is a fair question, and the answer is subtle. At a very shallow level, yes, you can think of holophase as a radical reorganization of existing physics. Many of the equations, experiments, and effects we discuss are already known. We are not claiming that interferometers, holography, quantum phases, or topological effects were unknown. What is new is the ontological interpretation and the discipline we impose. By treating phi as the only primitive, and by forcing every other quantity to be expressed as a phi functional, we gain several things at once. We get a unified measure of what counts as physical. We get a natural home for phenomena that have always looked phase-like and slightly mysterious, from quantum interference to Berry phases and beyond. We get a clear set of falsification strategies, because any phenomenon that cannot be so expressed becomes a challenge to the core of the theory. Most importantly, we clear space for the next step, deriving time, space, motion, energy, and all the rest as emergent features of the phase field, rather than as primitive scaffolding we must assume from the beginning. That is what we will begin to explore in the next part. For now, the key message of part 2 is this. Holophase proposes an invisible, continuous, cyclic order field called phi as the basic layer of physical reality. You never see phi directly, you see phase differences, gradients, and patterns of alignment. Everything you now call a physical quantity is, in principle, to be re-expressed as a function of phi and its derivatives, measured on finite experimental windows with clear error bounds. This move is both unifying and dangerous. It unifies many domains of physics under a single alphabet, and it makes the theory easy to falsify if any robust phenomenon refuses to be spelled in that alphabet. If this feels unsettling, that is good. It means we are doing what we promised at the start of the series, taking the familiar story of energy in space-time and asking whether it is truly fundamental or whether there is a deeper rhythm underneath. In part 3, we will begin to see how that rhythm can give rise to the dimensions themselves and how the invisible phi can wear the visible masks of time, space, and motion. Before you move on, I invite you to notice how often your own life is already governed by invisible patterns. You do not see trust, but you feel its effects. You do not see meaning, but it shapes your choices. Phi, in this story, plays a similar role for the physical world. Unseen, but structuring everything. With that thought, we are ready to step into part 3, slowly, carefully, and without blind faith.